Hello, I'm Eric Miskell with EMSNOW, and welcome to this webinar featuring Ko Young, the title of which you see on the screen there, Driving Down Defects, Optimizing Pin Inspection for Automotive Electronics. We thank you for joining us today. Sorry for the delayed start, but I think you'll find the time spent today well worthwhile. Our presenter today, you'll see on the screen, is Gustavo Jimenez. He is the Mexico Sales Manager for Ko Young America. Let me explain the structure of the webinar today. What we will be doing is Gustavo will be taking us through some slides and doing a presentation. As soon as that is over, we will open it up for Q&A. So from a housekeeping perspective, what I would say is all of our guests and the attendees will be on mute. This webinar is being recorded for rebroadcast later on EMSNOW. And if you have any questions or comments that you wish to pose, please do so using the question icon on the bottom of your screen there. We will hold questions until Gustavo finishes his comments, though. So, but feel free to share those throughout, and we should have ample time at the back end to address any questions that our audience may have. So, that said, let's get into it. Gustavo, welcome. Good to see you again. I'm glad we get to do this. For the benefit of our audience, why don't you begin by just introducing yourself, please, sir?
Well, thanks, Eric. Sorry for the delays. There was some technical issues, but we are here. And first of all, we want to thank Eric and the EMSNOW team for arranging this webinar. I'm Gustavo Jimenez. I'm part of the sales team of KY America. I cover part of the Mexico territory. I've been in Ko Young for 3 years, more than 3 years. I'm very happy to join, to be part of this great family, as we call it. So this is part of what I am. Let's start it.
Excellent. Well, Gustavo, the screen is yours, sir. I would allow you to just proceed.
Perfect. Okay. So thanks for taking the time to attend this webinar. Basically, the objective of this webinar is to provide you all customers with tools to optimize the inspection of products that have pin, terminal, and connectors. We know that there are a lot of applications out there, from PCB application to final assembly applications. And I'm sure that we can provide you with great tools so you can optimize the inspection in these products, okay? So our agenda will consist on, first of all, review the KYP3 model lineup. This platform is very diverse, so we will review the lineup. We will explain why to add or why to include API system, automated pin inspection equipment, to your production lines, to your production environment. We will talk about the system configuration. As I told you, there's a lot of versatility in this platform, and we will talk about how flexible is this platform, and we will provide some examples. And finally, the benefits of the KYP3. This is what we are going to see. And talking about the application, well, we can talk that this kind of machine can be applied in different production environments, from the conventional SMT line, pins that have pin with SMT mixed hybrid, we call it hybrid, to the backend applications from press fit through hole or final assembly process. So as you can see, you can apply, thanks to the machine versatility or flexibility, you can apply this solution to multiple production environments, multiple scenarios. Some of the examples for these applications are the single pin application, 4 pins, the hybrid 4 pins with SMT components. That's for the PCB side. In the final product or final assembly, we can measure press fit assemblies or final assemblies with connectors or terminals. And these are some of the examples of that with products that we can apply this technology. As you can see, we can go from a bare PCB with connectors to a final assembly ready to be shipped to the, let's say, an automotive customer. So as you can see, we are very flexible and machine is very diverse, so we can apply this technology to multiple scenarios. Talking about the model lineup, basically, we have the automatic machines and the manual loading machines. For the automatic line, we have the A1 machine, which is a machine that can inspect PCBs in a normal SMIMA environment, as any production line for SMT. And we have the A3 machine, which is a machine that can work in an automatic line, but with a Rexor pallet environment. This is very common in automation. So you can apply this to an existing SMT line with SMEMA or to an existing automating line with Rexor pallet handling. In the manual feed, in the manual handling, we have the M1 machine where you can manually load a PCB with terminals, connectors, or pins. Or we have the M3 machines, which is for final assembly, and we create a pallet jig with the capability to allocate a final assembly and to manually load this assembly for the inspection. So as you can see, there's a lot of versatility in a single platform. We have up to 4 different models when we can cover most of the manufacturing environments in the industry. And talking about examples for these applications, for the A1 and M1 machines, these are some examples: single pin, 4 pins, press fit pins, different kind of single pin, 4 pins in both sides of the board, and what we call hybrid, which is 4 pins or terminals with SMT. This is very common in especially for the automotive industry. These applications can be covered in a very good way with their KYP3 systems. For the A3 and M3, these are the different examples, press fit examples, and final assembly. This is very important because let's say that you already have a production line manufacturing these kind of products, and you want to inspect these assemblies before sending it to your end customer. Well, we can design a pallet to allocate these assemblies, and you can measure the terminals and the pin even inside of these applications, so you can be sure to ship your assemblies with no failures, with no issues to your final customer. This is very important because there are no OEM machines at the moment to inspect this kind of environment. Usually what customers are using right now with not very good results is an integration with cameras, an integration with some automated vision system. But at the end, since it is not an OEM solution, it's kind of complicated to keep up with good results with this kind of applications. Well, talking about the machine specifications, in the PCB side, we can go from 510 by 510 mm PCB size to 50 by 50 mm, which is a very good range for PCB. And for the final product or final assembly, we can have a piece as an assembly 350 by 300. So it's a very good area, a very good piece, and we can inspect that within our machines. There are some optional items such as the extra wide body machine or the AMEC camera for high-speed applications. We can provide any detail if needed. We have the machine spec and we can share with you with no issues. Well, why we recommend to add an API system to your production lines? Well, there are some very good there are very good reasons to add this. The first and the most basic will be to find defects without false calls and escapes. Well, this is something that any inspection device, any inspection machine have to offer, right? To find the defects without false calls and escape. That's very important. In order to find those defects, we need to have a specification of a definition of what a defect is. If you have that, then your system need to be able to measure. That's super important because without measurement, you cannot control. You need to measure if you want to control your production. Well, what you can expect from a Co-Young 3D API is a repeatable and accurate measurement, which is very important, and a high performance on defect finding. That's very important. We can offer you a repeatable and accurate solution that will provide you with a high performance on defect finding and the ability to improve your previous process. If you apply all the data, because we're measuring, if you apply that data to your previous process, then you're gonna have the ability to improve that process for sure. Well, this is a very basic example of how of repeatability and accuracy, right? The center your inspection data is, the more repeatable and accurate you are. So other solutions in the market, especially the integrations with cameras, they do in order to recreate the shape of a terminal. They do more than one measurement on a single pin. They move the Z-axis on the cameras in order to capture the complete pin height. And sometimes the first issue that you have by doing that, it's cycle time issues. And since this application is focused to the automotive industry, you cannot have cycle time issues, right? Because you have a takt time in your line. You need to meet that takt time, and it's very important to be efficient on the time that you take to inspect. And the other thing is that you can have stitching issues on the reconstruction because as you are not measuring on a single shot, you can have these stitching issues. Well, with your system, as we are repeatable and accurate, we can measure up to 20 mm on a single shot. In a field of view, we can measure all the pins within 20 mm in a single shot, and that's very, very good for repeatability and accuracy. That's the basis of that. So how we do that? Well, we are basically using the optical triangulation, top camera, light and shadow emission, and we create we utilize the Moria systems with this something that we already used. It's a technology that we introduced to the market with our SPI and our AOI systems years ago. It works very well on that environment, and we adapt the hardware in the machine in order to utilize this concept. And what we are getting parametric based measurements in the pins. So that's how we create this data driven inspection. So something else that what we are utilizing in our API system is the stop and go technology, same as we do in our SPI and our AOI systems. We stop, we capture all the measurements, all the images in order to measure, and then we move to the next field of view. So the vibration and the focus issues are out of the equation because we remove that by stopping the inspection unit and taking those images in order to make the measures. So what are the items we can inspect with these machines? Basically, we utilize true 3D algorithms with some combination with 2D as well. And we can measure the dimension of the pin, dimension in X, Y, and Z. We can measure the center of the tip of the pin, which is very good. We can measure the path overhand of the pin. We can measure the inner distance of the pin between in the 4 pins, in the 4 terminals. One of the critical measurements is the distance between the 2 terminals or two of the 2 terminals or between terminals. We can measure that in a very good way. We can measure pin to pin distance. We can measure presence or absence of a pin. We can measure, this is very important, the shoulder couplanarity of the pin. And one of the newest measurements that we can offer, we can measure the angle of a bent tip. That's very important. We can measure that in degrees, and we can include that as an algorithm to measure. So for these measurement items, we can offer a very high precision level on the high position, on the position of the pin, on the inner distance, on the angle. You can see those specifications here. And by having that high precision level, you can expect a low variation of the measurement, resulting on high first part yields and low FPMOs. That's very important. So talking about the system configuration of a KYP3, as you were able to see, there's a lot of flexibility in this platform. We will provide some good examples in that. Basically, for the talking as an example with the entry platform, well, this if you remember that the M3 is the machine that you can manually load a final assembly to be inspected. Well, we create a housing jig for this particular assembly. We can insert that assembly with in this jig, and then the machine will do the rest. We can inspect, and we can also include some scanners with inside the machine, so the 2D or barcodes can be read and can be included in the traceability of the measurement. We will see some quick examples. I have a couple videos for you, so you can see in a better way. So here, the operator will go manually load the device, the final assembly, machine flip 90 degrees that assembly, and do the inspection. If you need to read the barcode or a QR or something like that in the assembly, we can add scanners to the machine, so it can be that information can be added to the traceability. So this is a good example or how flexible. For this particular case, that jig was designed to allocate that assembly, but you can have any if the measurement of the piece are within the spec of the machine, you can have as many as you need, so you can measure all the all your assemblies. So if we summarize the handling option for the A3 and M3 machines, we can have the jig that it's designed specifically for a certain application. We can have this is for the entry machine. We then, for the A3, remember the A3 was the automatic line for Rexor pallet. We can also design for you a pallet to allocate your sample, your end product. But very important that we can work with automatic arm like this, so it can be integrated. That robot can be integrated to the machine, so it can load and unload the piece. We have an integration suite that can work with any PLC based robot arm. So that's very important. We are, as I told you, one of the bases of this platform is flexibility. So we are super flexible with this platform. So, and the jigs can have a flipper, as you see. For the A3, we can design a plate with the Rexor pallet to allocate any kind of assembly that are within the spec, and we can have the robot interface. And the scanners can be added to the machine. I have another example for you. This one is for the M1 machine. This is a very good example because you can manually load a PCB, and then the PCB can be inspected, and it can be sent out from the machine from another lane. So you have 2 lanes to work with the inspection. So you load for the upper conveyor, and machine, and the PCB is upload from the down conveyor, so you can maximize or your inspection time. So for the entry, we have single stage and dual stage. Again, if you need to meet certain inspection time, we can maximize the machine utilization by having a dual shuttle to load and unload. I have an example for you. So for one of the lanes, it's going to inspect, and then while that side is being inspected, you can load another piece in the other stage, so you can maximize the machine utilization. So flexibility is the basis for this platform, and that's something that you cannot find in the normal applications for SMT technology. In SMT, you know, we have this SMIMA or Hermes-based transportation or handling. In this platform, we are a lot flexible. So there are some special functions designed for this machine, and we are utilizing the same definition for measurement that the CMM machines use. For the CMM machines, the CMM machine compares the base point versus the top, the height of the pin, and then calculate the pin height. Well, in our machine, we are doing a very similar approach. No matter the finish of the pin, because normally they are not so repeatables, but no matter the finish of the pin, we can apply the same concept. From a base plane, we are able to identify that base plane, and we can measure the height considering that base plane. So if you see, we are utilizing a similar approach that CMM machine, but in a very faster way. So there are other advantages with this machine. between product to product, maybe there are different base planes. We can, as the optical units can adapt. So we can adapt from a product with we can go inspect two different assemblies in the same machine, even if they are different heights, because the Z-axis in the machine is movable. Obviously, we inspect in a one shot, but the Z-axis is adaptable to the product. And not only to the product, we can do the same thing. If we have an assembly with different base plane, the machine will adapt to this base plane, so we can measure in different heights in the same assembly. We inspect in a single shot the 20 millimeters, but we can adapt our inspection height or inspection unit to different heights. We have some software validations in the machine. If your end customer asks you to validate every certain time with a golden unit, we can program that in the machine. We can have external verification units, and machine will stop until you measure that and confirm everything is good. If you want to go deeper on the verification, we can add a verification tool inside of the machine. So from time to time, machine can be auto verifying that everything is everything is good, and you can program every certain time, and you can restrict the utilization of the machine in regards to the results. So in the programming side, is very similar to our AOI systems. You base your programming on Gerber and CAD data. You can add the geometry of the pin and the inspection conditions to the pin, and then you can have your debugging process, same as you do with an AOI system. Well, something very important in the automotive industry is the MES. I can say that maybe all the production line have MES integrations, because traceability is super important in automotive industry. So we have a lot of plugins, and we are partnering with a lot of guys to integrate, to have a complete MES integration. We can share, or you can extract certain information from the machine, and you can also work with Aegis, IPC, CFX, Hermes, ITAC, with some other partners. So you can have a complete MES integration. And if you are familiar with your SMT products with SPI and AOI, then you know the CaseSmart Tools. Well, the KYP3 it's also equipped with the review station, and all the CaseSmart Tools are available. So you can monitor, optimize, and visualize your process through these software tools, which are super complete and will provide you with extra tools to control your production. Well, this is all what I have right now. Eric, I hope that this can help you to apply this technology in your production line, and we will be happy to know about you. If there are some applications that you want to talk with us, well, you can go through Eric, or you can contact us direct. We will be happy to help you.
Okay. Well, Gustavo, thank you for that. And let me just encourage our audience. There's some questions coming in. We'll do those in just a minute here.
That's great.
If you have some questions or comments you wish to, please add them down below in the Q&A tab down there. Let me begin by saying, though, Gustavo, yeah, I mean, in preparing for this, this was actually very cool technology. And I think the seeing it, and the videos and all, and what you were just doing there, I think that really brings it to life. And I think you make a good point for kind of the versatility and the flexibility of the unit there. So let me go through some of the questions that people have been posing. and I'll do them in order. So how does this machine connect to other machines in the SMT process for an integrated Industry 4.0 solution? You touched on that a bit at the end, but maybe say a little bit more about that, please.
Well, this machine, especially the machines that work in an automatic line, the A1 machines, are fully connected to SMEMA, but we also are connected with IPC Hermes, which is the next SMEMA, let's say that. And we have a complete solution to export data or solutions that are already done with some of the integrators for the MER system. So you can expect a fully connection with any kind of production line, the normal production lines, and also to export or to work with any of the MES integrator in the market.
Okay, excellent. Next one has to do with the ROI on that. What is the expected ROI for this machine if it's added to the existing line?
That's a very good question. I will go back to the spec.
Okay.
So the FOB size for the 4M machine is 30 by 30, which is a very good one. If you want to upgrade and have a faster inspection, you can get the 8 meg machine, which is 56 by 56 FOB size.
Okay. Now, what the question was, though, Gustavo, had to do with return on investment. If somebody is purchasing this machine and adding it to an existing line, that's what we're asking about. So.
Okay, got it. Well, that's a good. That's also a very good question. It will depend, obviously, of how under control is your line right now. If you're having a lot of scrap, by utilizing a machine like that will allow you not only to detect the defects, since it's measurement-based inspection, you can apply that measurement to improve your process, and by doing that, you will stop making bad units. So it will depend on your situation, and usually for inspection system is not that easy to calculate the return of investment because it depends of your current situation with your scrap with the scrap you're making. So, but I can if you're having a lot of scraps, I think that you can have a 1 year return investment if you apply a system like this. I'm guessing.
Good. Yeah. No. I appreciate that. And listen, I noticed and you addressed the issues of the bent pin and the models handling the final assembly, which was impressive. What about I was caught by what you showed about the hybrid products, right? Where there's maybe SMT end pin. So speak to that a little more. So is that becoming more common, or are those more challenging?
No, actually, it is becoming very common, super common, because customers in the automotive industry, they are replacing some connectors in the boards with insertion pins. So we are seeing a lot of applications that customers have with mixing technology, SMT together with pin-in-paste applications. So I think for the current applications, 60–70% of the applications that we've been sold for this platform are hybrid applications. And something that I'm proud to say is that if you consider the 10 biggest automotive electronic manufacturers in the world, this machine, the KYP3 machine, is already qualified for 5 of them. 5 of the top 10 of the and we are selling machines to 4 of them already, only in the Americas. So if you consider all those big guys with big names manufacturing electronics for automotive, this machine is qualifying for a lot of them, and we have active sales in Americas with these customers. Last week we received a PO for 2 machines for an automotive manufacturing company in Monterrey, Mexico. Mm-hmm. So there's a lot of traction and there's a lot of success because we are looking into a technology that was nobody in the inspection market can offer a solution like this.
Mm-hmm. You know, and that actually leads to one of the other questions somebody has posed. It is, what is the learning curve for people working on these machines? So these customers that are putting in, how hard is it for them to learn to operate this?
Well, as an inspection machine, if you have some experience in AOI, or if you have some experience in inspection, it's the same concept. We are not reinventing the wheel here. It's a very basic inspection system. Obviously, it's very strong because we are measuring, which is a very strong concept in the inspection industry. If you measure, you're gonna have success in inspection. So it's not that complicated to learn how to utilize the system.
Okay, good to know. Now, you know, I was struck also by comments you made about the current solutions that their OEMs are doing. So the integration of cameras into things. It sounded like an imperfect system, but it's just kind of a workaround that people have developed to kind of address this issue. Speak to that a little more and tell me also, so is the P3 kind of the first of breed in this type of, for this type of machine?
Yeah, a lot of our customers are suffering because, well, they have a need for inspection, right? Because the process is demanding an inspection. So since there was not a OEM product, what they do, they go to these camera manufacturers and they integrate systems with multiple cameras to try to have a better coverage in inspection. Well, the issue from those systems is, first of all, as it is not an OEM solution, well, the support is limited. Maybe only the guy that put together all that camera range will be able to support them. The precision, the accuracy is not as expectable, because it's impossible to get this accuracy and precision levels with an integrations. So we see that customers are suffering a lot with those solutions. And that's why we are being very successful on applying this technology, because we are going from an integration with a low accuracy, low precision, with not that much support, to a brand with the leadership in inspection in the market, with a complete support team in all the world, a multinational brand with super high accurate and precision rates. So at the end of the day, we are providing customers with extra tools to be more, to have a better production environment.
Okay, very, excuse me. So even though the title of our presentation today referenced automotive electronics, the application of this isn't just with the pin inspection. That goes into other sectors as well, right?
Yes, we are also seeing a lot of there in the electronics. There are the high-powered applications, and they are not only for automotive. We are seeing a lot of that in the communications, in some medicals, some industrials. So this machine, I mean, is focused for the automotive industry, but outside of the automotive industry, for those high-powered applications, we are having a lot of requests, and we already saw a couple of machines for the industries outside of the automotive industry. Backplanes is a good example. There's a lot of pins, control box, power modules for solar energy. There's a lot of there's a wide range of applications with pins. I mean, in a good examples, we have a customer here in Mexico as well that manufacture only connectors. They don't do any other electronics, or they don't do any PCB, but these guys manufacture and connectors. And right now they have some camera integrations, and we're working with them to apply, or it was the M1 machine they fill a pallet with connectors, and we can inspect, and they are having very good results. So yes, there are a lot of application outside of automotive.
Okay. Yeah. Listen, Wade, we'll use this. One last question came in here, and let me just pose it to you.
For sure.
What is the false call rate and escape rate on a high mix and complex card in the field?
Well, that's a very good question. We can expect that for sure you're gonna be up to 95% yield, and if you program the machine well, we can guarantee 0 escapes. That the escapes are based on how well programmed is the machine. So the algorithms in the machine are enough accurate and enough good to allow customers to don't have any escape.
Okay, well, that sounds good.
Oh yeah. And we do the same thing in our AOI and SPI systems.
Okay. Well, listen, this has been excellent, and unless there's any last questions that somebody wishes to pose, I will take this opportunity to thank you, Gustavo, for this. I think this has been very insightful. It's been very informative. I would encourage anybody in our audience or people who see this that who have any questions about this or interested in what Gustavo has been talking about. You can certainly find him on LinkedIn. As always, I always point people to LinkedIn to get a hold of people. So you could look for him there. He's updated. If for some reason you cannot find him, as he indicated before, get a hold of me and I will put you in contact with him directly. Gustavo obviously is in Mexico, but the product is sold globally. So if you're calling from another region and need to be connected with somebody in your region, reach out, and Gustavo or I will do our best to help get you connected.
For sure.
Excellent. Gustavo, thank you very much. This has been very insightful, very informative, and quite impressive what Co-Young has put together here. So maybe later in the year at some point we can get an update on what's happening and how the adoption and the performance of this is going.
For sure. Thanks, you, Eric, and thanks to the EMS team for putting all this together. And especially thanks for all the audience that make the time to connect. We hope that the time you spend with us can be useful and that information can be utilized in your process. And we hope to hear from you. Thank you.